Welcome to Mathematics Mastery with Bethel, your mathematics teacher. Ready to conquer maths? Let's get started. Welcome to Bethelmatics Academy. So today I'll be taking you through real-life application of Pythagoras rule. If today is your first time on this channel, please do well to hit the subscription button, like the video and share with friends. In my previous video, I've shown you how to make calculations using the Pythagoras rule. So if you are still having challenges in understanding Pythagoras rule, please do well to watch my previous video on mastering Pythagoras rule. All right, so this is example number 1. So the first thing to do is to make a pictorial representation of this question. Solution. All right, so from this question, we can see that a ladder was mentioned, a wall was also mentioned. Now, we all know the nature of a wall. Walls are usually vertically straight. So let's represent a wall with a straight vertical line. And then the question says that a ladder that is 7 meters long leans against the wall. Of course, that definitely means that if this is the wall, then a ladder should lean on the wall this way. This is the ladder, and they say it is what? 7 meters long and leans on the wall. Of course, the wall must be vertical. And then the question asks, say the ladder's foot is 2 meters from the wall. This is the ladder's foot. This is the wall. So the question said that distance from here to here is 2 meters. Yes. So definitely this has formed a right-angled triangle. So where is the right angle in this triangle? Of course, it is very clear that it is where the wall meets with the floor. So this is your angle 90 degrees. So you can choose to call here A, call here B, and call here C. Next, remember the question says we should calculate how far up the wall. So we should calculate the distance from here to here. So we can call the distance AC our X. So that's what we are looking for. So the next thing to do is to write down your Pythagoras rule. So your Pythagoras rule states that hypotenuse square is equal to opposite square plus adjacent square. All right, so after writing your Pythagoras rule, the next thing is to substitute. Remember, line AB is your hypotenuse. The reason is because line AB is the line facing your angle 90 degrees. Line BC and line AC becomes your opposite and your adjacent, because there is no angle that is specified here. There is no angle that is specified here. So you can call line BC your opposite and then call your line AC your adjacent. Okay, so let's substitute appropriately. So line A is our hypotenuse. So we write, in the place of hypotenuse, we put 7 square is equal to, and then line BC is our opposite, because remember, no angle was specified here, no angle was specified here. Because of that, you can call here your opposite, and you can call here your adjacent. So line BC is what? 2 meters square plus our line AC is what? X, because no value here. This is the line we are asked to determine. This is the height of the wall we are asked to determine. So we put our X and then bring down the square of the adjacent. The next thing to do is to evaluate. So let's go. 7 square will give you what? 49. Because 7 square means 7 times 7. And 2 square will give us what? 4. Then plus X square. So the next thing to do is to collect like terms. X square. So 49 minus 4 will give us what? 45. It is equal to what? X square. So the next thing to do, you can start to invert we write it as x squared is equals to 45. So taking the square roots of both sides, x becomes equal to square root of what? 45. And x is equal to, the square root of 45 becomes, so the square root of 45 is equal to 6.7 meter. Remember, the units of our problems are in meter. So the square root of 45 is what? 6.7. This is one example of real-life application of Pythagoras rule. So this is example number 1. Let's go to example number 2. So this is question number 2. So the question asks, a plane, this is also another real-life application. A plane flies northwards for 400 kilometers. It then flies eastward for 150 kilometers. How far is its starting point? Okay, so one thing that can help you to solve this problem with ease is understanding your cardinal point. Remember, if this is your cardinal point, okay, so this is your cardinal point. So here is called the north, here is called the south, here is called the east, and here is called the west. So when you hear that a plane flies northward, it means, let's assume this is the starting point. It means the plane started here at the origin and moved towards this direction because this is north. So the question says a plane flies northward. Definitely, solutions. So the first thing to do to be able to solve this problem is to make a kind of pictorial representation of this movement. So let's interpret the question accordingly. The question says a plane flies northward. So let's assume the plane started from here and then it goes northward in this direction. And what is the distance it covered in the north direction? 400 kilometers. So this is 400 kilometers in the north direction. It then flies eastward. Okay, so this is where it was at the end of 400-kilometer movement. Then which direction is your east? Which direction is your east? East is this direction, 450 kilometer. Okay, so the question is asking how far is its starting point? Of course, this was where it started from, and this is where it is currently. So the question is asking what is the distance from here to here. So this is a typical right angle triangle. So where is the right angle in this triangle? The right angle is here. All right. Then this place that has no value becomes our x. Okay, so the next thing to do is to write down your Pythagoras rule. It states that hypotenuse square is equal to opposite square plus adjacent square. Okay, remember, we can call here A, we can call here B, we can call here C. So remember, your hypotenuse is the line that is facing your angle 90 degree, and that is line what? AB. And what is the value of line AB? The variable there is x. So put our square is equal to, remember, since there is no angle here, this line can be your opposite, this line can be your adjacent, this line can be your adjacent, this line can be your opposite, and this other line can be your adjacent. So it does not matter because angle has not been specified. So let's substitute accordingly now. So let's substitute the rest of the values. We can say here 400 square plus 150 square. So x square is equal to 400 square simply means 400 times 400. That will give us 160,000 plus 150 square means 150 times 150. That will give us 22,000. Means that x square is equal to 182,500. So the next thing to do is to take square root of both sides. X is equal to square root of 182,500. So this will give us approximately 427 kilometers. So it simply means that when the plane had gone from A position to C and from C to B, it is 427 kilometers away from its starting point. So this is another beautiful application, real life application of the Pythagoras rule. Let's take the third example. So this is example number 3. So this is example number 3. So the question says a student cycles from home to school first eastwards. Remember, east direction is this direction. To a road junction 12 kilometers from home. Then southwards to school. If the school is 19 kilometers from home, how far is it from the junction? So solution. So the first thing to do is to make a pictorial representation of the question. Okay, a student cycles from home to school first eastward, of course. If a student cycled east direction, it means he cycled this direction. This is east, this way. And what distance did he cycle eastward? The question says 12 kilometers. Okay, from home. Then southwards to school. So if this is where he is at the moment, going south direction, south is this way. This is south direction. So he now cycled south direction. If the school is, okay, south direction, they didn't give us the value. The distance he has cycled in the southward direction, it is not given to us. If the school is 19 kilometers from home, so this is his school because this is his final destination, which is his school. And this point is 19 kilometers from home. This was his home, and this is school. So we can join here with a straight line, giving rise to a right-angled triangle. And the distance from home to school, according to the question, is 19 kilometers. Okay, so definitely our angle 90 degree is here. Yeah, this is angle 90 degree. So you can call here A, you can call here B, you can call here C. So let's call here Y. All right. So the next thing to do is to write down your Pythagoras rule. Say that y square, hypotenuse square is equal to opposite square plus adjacent square. All right, the next thing to do is to fit in your values. Remember, your hypotenuse is the line AC because that is the line that is facing your angle 90 degree. So hypotenuse is what? 19. Then we bring in our square is equal to, because there is no angle here, you can call here opposite, you can call here adjacent. So put in 12 square plus y square. Okay, so 19 square is equal to 361. That means 19 times 19. And 12 square is equal to 144 plus y square. So the next thing to do is to collect like terms. So let's collect like terms. It becomes 361. 144 here is positive. If it crosses equal sign, it becomes negative. Minus 144 is equal to y squared. So 361 minus 144 will give us 217 is equals to y squared. So I can invert this to become, I can rewrite it to be y squared is equals to 217. So the next thing to do is to take square root of both sides because I want my y to be alone. So y is equal to square root of 217. So that y is equal to, so the value of the square root of 217 is approximately equal to 14.7 kilometer. All right, so the young man The distance between this road junction and the school is 14.7 kilometers. You can see that the real life application of the Pythagoras rule is very simple. Okay, so I'm going to drop example number 4 as your exercise. All right, so this is example 4, your exercise. So try it, confirm your answer with my answer in the description box below.